Today I will teach a geometric series. I already say that what is series, what is the convergence, what is the meaning of convergence, etc. Here I define geometric series. Geometric series is a series of the form A plus AR plus AR square plus AR cube plus AR power 4 plus etc. AR k minus 1. Generally, we can write summation A R power k minus 1, k equal to 1 to infinity. This series, above series, can be written as summation k equal to 1 to infinity a r power k minus 1. I emphasize that geometric series is a series and each terms are given by first term is a 1 equal to a. Second term a2 is a multiplied by r. Third term is a2 multiplied by r, so ar square. A4 is a3 multiplied by r, ar cube. Similarly, a common term multiplied by the last term, then we'll get next term. So a kth term, ak is ak minus 1 into r. ak minus 1 is ak minus 2 into r. So this is a into r power k minus 2. So here we got a into r k minus 1. So a common number multiplied by the last term, then we'll get next term. Such a series is called geometric series. So this series can be written as a plus, next term is ar plus, next is ar square plus, next is ar cube plus, etc. ar k minus 1. So generally it can be written as summation a r k minus 1 k equal to 1 to infinity. This is the geometric series. A can be say that first term of geometric series. First term of geometric series. And R be the common multiple. That is called the ratio of the geometric series. Common ratio of geometric series. Okay. Next, we can discuss its convergence. So we know the geometric series is summation a r k minus 1 k equal to 1 to infinity. So we can discuss what is r equal to 1. The common ratio is 1. Then what we'll get? This can be written as a plus ar plus etc. ar k minus 1 plus etc. This is the geometric series. We take the common ratio is 1. We get geometric series is a plus next term is a plus next also a plus etc. a plus etc. Okay. So it's a partial sum. Sn can be written as first n terms. So a plus etc. a. So in a partial sum is first sum of first n terms. So here first two n terms are A. So find the sum of first two n terms. We get Sn equal to Na. Sn equal to Na. As n will be large or n tends to infinity, this partial sum Sn equal to Na also converges to infinity. Therefore, we can say at r equal to 1, our geometric series r equal to 1, geometric series is divergent. Here we will discuss case of r equal to 1. R equal to 1, we get a partial sum is in A. The convergence of series is, it's a partial sum if the partial sum, corresponding partial sum is convergent. Emphasize that the partial sum of infinite series is convergent. If the partial sum of infinite series is convergent, then we can say corresponding series is convergent. Otherwise, the partial sum is divergent, then we can say corresponding series is divergent. So here the partial sum is divergent to infinity. So this corresponding infinite series is divergent. In this case is r equal to, the ratio is 1. So geometric series, so we can say the remark summation a r k minus 1 k equal to 1 to infinity is divergent if r equal to 1. Okay. Next we can check r equal to minus 1. Okay. R equal to minus 1, our series is a r power k minus 1. K equal to 1 to infinity. That means a plus ar square plus etc. ar k minus 1. So first term is a. Second term a r. A r means a into minus 1. So minus a. Next is ar square. That's a minus 1 square. So 1. Next is ar cube. So a minus 1 cube minus a. So minus a. Minus 1. So minus a. Next is plus a. Next is minus a. Plus etc. A or minus a. So the ending k is even. We got a. K is odd. This a is minus a. So depends on the n. N is even. Is it right? I will explain once more. So we can take n equal to 5. So what is the partial sum of n equal to 5? So we can write first term is a, second term is minus a, third term is a, r equal to minus 1. Minus a r cube. A plus a. A minus a. N equal to 5. 5. So a power r, a r power 1, a r power 2, r power 3, r power 4, a r power 5. So otherwise n equal to 6 means one more term minus a Sorry. N equal to 5 means we know. Okay. Once more I will explain. First I will explain in the case of n equal to 5. So n equal to 5. We know n equal to 5. A is 5. That is equal to A plus AR plus AR power 1, 2 plus AR cube plus AR power 4. Because in the case of K, AR power K minus 1. So first term, second term, third term, fourth term, fifth term. So in the case of R equal to minus 1, we get A minus A plus A minus A plus A. So A minus A 0, A minus A 0, we got A. So similarly, n equal to 7. You take n equal to 7. So A minus A plus A minus A plus A minus A plus A. Okay. So these two cancel, these two cancel, these two cancel, we get A. So we can generally we say n odd. So Sn equal to A. Okay. Next, n will become even. So Sn can be written as S2 is S2 means A1 plus A2. So A1 is A and A R. So here A minus A R equal to minus 1. So that is equal to 0. Next you consider S4. So A minus A plus A minus A. So that also 4. Next you take S6. So we got pairs. So we got 0. So Sn equal to 0 if n even. So generally we can say in the case of geometric series, it's a partial sum Sn equal to 0 if n even and A if n odd. Is it right? So here we got the series convergence to 0 or Sn in the case of even Sn converges to 0. Sn converges to A in the case of n is odd. So we got two limit values. In the sequence of Sn, we got two limit values. In that case, we will say Sn does not convergent. Sn will divergent. So first already we proved R equal to 1. In the case of R equal to 1, Sn divergent. Here we got R equal to minus 1, also Sn divergent. So we can conclude the geometric series is divergent in the case of R equal to plus or minus 1. Okay. Next we can check others. So we can write, generally we can write the geometric series. Generally we can write the geometric series summation a r n minus 1 k minus 1 k equal to 1 to infinity. So a plus ar plus ar square plus etc. ar k minus 1 plus etc. This is the geometric series. First of all, you take a partial sum, n partial sum. Sn equal to a plus ar square plus etc. ar power n minus 1. This is the partial sum, n partial sum. You multiply by this one to r is n equal to ar plus ar square plus ar cube plus etc. ar power n. So we got two equations, Sn and Rsn. And you take 1 minus 2. So Sn minus Rsn equal to A minus, here no A. So we can write A. AR minus AR, 0. AR square minus AR square, 0. AR cube minus AR cube. Similarly here AR in minus 1. So all these terms are cancelled. We got AR power n. So A minus AR power n. So Sn is common. You can take outside y minus r equal to A1 minus r power n. So we can write Sn equal to A1 minus r by 1 power r, 1 minus r power n by 1 minus r. 1 minus r power n by 1 minus r. Okay. So we got the partial sum is a into 1 minus r power n by 1 minus r. If mod r less than 1, r power n is converges to 0. Mod r less than 1 means, I emphasize that, mod r less than 1 means r can be 1 by 2. R can be between minus 1 and 1. So we can take r equal to 1 by 2. So 1 by 2 a plus a by 2 plus a by 2 square plus a by 2 cube plus etc. A power 2 power n. So n will large, 2 power n will be large. So a by 2 power n converges to 0. So that similarly any of the number in between minus 1 and 1, its a power will become converges to 0. If you have a doubt, you can check. So any number r between minus 1 and 1, its a power will converges to 0. That's why we say if mod r less than 1, r power n converges to 0. Mod r less than 1 means r in between minus 1 and 1. So r power n converges to 0 as n tends to infinity. So we have Sn equal to a into 1 minus r power n by 1 minus r. In this case, we can write a minus a power n by 1 minus a. Mod r less than 1, r power n converges to 0. This term converges to 0. A r power n converges to 0. So we got a by 1 minus r. Here r, 1 minus r. Okay. So we can say a sen converges to A by 1 minus R if mod R